Hi. Good evening.
Good evening.
I want to talk to you about cloud health and cloud monitoring. So, a little bit about Sardina Systems, who we are. We are a OpenStack Kubernetes platform software company. We provide a product with OpenStack and Kubernetes pre-integrated with a range of operations tools around it to make operations life of OpenStack and Kubernetes platform easy, simple. We are a UK company, but the team is very much spread across Europe. Some folks in Romania, Russia, Slovakia, and I'm not going to bore you more about the company. So let's move on to talk about clouds and enterprise.
Can you talk about yourself quickly? Who you are, what are you doing there?
Sure. I run the technical team and one of the 3 founders. And today, I'm notionally based in the UK, but my wife doesn't necessarily agree. Clouds and enterprise. Let's look at the user's perspective. What's the objective? What do we need? So from the user standpoint, cloud is to get you speed of execution, get you reliability, get you flexibility. And for some audiences, they want cloud to be cost efficient. Yeah? Now, if we look at the private clouds, all these items are certainly valid items to want. Yeah? For the developer, execution speed basically means quick get going, programmable, and all the usual good stuff about cloud, which I'm sure I don't need to tell you what they are. Yeah? For the program manager, they wanted a platform that is easy to get going, projects can be brought up very quickly, and also very easy to recruit new folks. But for the enterprise, it's really about cost. So with that, how are we going to fuse this flexibility, the demands of the users? How do we deliver that from an infrastructure operations point of view? For the users, they expect the cloud to just work. Really? Sure, it is a valid expectation. But in any case, is it a shiny new toy? Absolutely not. It's a production-oriented platform. It's a business tool. So, if we then focus on the reliability challenge is quite simple, quite simply defined. It's just keeping it up. How difficult can it be? What we find in a number of organizations is that increasingly companies are now finding younger developers who grew up in the AWS era. What this means is that this young coder, his experience is, I go to Amazon, I point and click, I've got a VM, fantastic, and I can now code. And for the coder, this is great. So young coder shows up at work, and enterprise runs private cloud. And young coder is told, yeah, we're going to bring down the cloud today for whatever operations. What is the young coder going to say? Oi, why are you guys so bloody incompetent? Amazon, it just works. So the issue about reliability is how do we ensure that we can get this thing to just work? But really, it's about preventing young coders screaming incompetent. You can't have that, right? So now, for the operations folks, sometimes they think, all right, so I have a young coder here saying, you need to keep it up. It should be simple statement. You just keep it up. But how? How do you do that? So sometimes I hear people saying, well, it's simple. We use standard monitoring tools. We monitor, and we know if it's having a problem. Yeah? So, And they say, let's turn to whatever tool X, sexy tool of the day, well-proven tool of the day, and voila, problem solved. Is it? Let's go one step further now. Let's look at the concepts behind monitoring. And these concepts apply to just about any monitoring tool. I'm not going to focus on any particular one today, okay? So the principle is this. First, you probe. And is it responding? Yes? Fantastic. We wait. Next cycle, we probe again. And still responding? Yes? Good. But if it's not, not quite sure. Let's probe 3 times. Still not responding. Fine, let's declare death and alert the operator. Very common, am I right? Standard operating procedure. Yeah. So once you alert the operator gets out of bed. Service consumer is no longer happy. Young coder is screaming, oi, you lot are bloody incompetent. No good, yeah? So what's missing? It's alerting after the fact. It's dead. And then you alert. Not good. The problem is the tool is basically looking for dead or alive states. So, all right. And then you alert when you find death. So I sometimes get the response, easy. Let's redefine the thresholds for alert. Really? So let's pause on that for a moment. Let's look at Life of Jane Doe. And you can substitute Jane Doe by any name. Okay? So now let's suppose that we were to detect only if Jane Doe is dead or alive. But then we're call the doctor only if Jane Doe is already dead. That's not so helpful to keep Jane Doe alive, is it? Right? So let's suppose we redefine the state to call the doctor. So do we say sneezing equals call the doctor? Maybe. But if so, the result is you've got a doctor's office jam-packed with sneezing Jane Does. Oh crap, we can't have that, can we? Not so helpful. So then sometimes I get this other response. Hey, it's easy, it's immutable system, so let's kill anything that is deemed to be unhealthy and let's go redeploy it. After all, it's immutable. We should be running immutable systems. We do not ever run kettles, and so we do not run pets anymore. We run only kettle. Yes? All heard that before? Yeah? So therefore, if sneezing and we then kill Jane, oh geez, then the result is we're going to have a lot of live but sneezing Jane Does buried 6 feet underground. So what do we need? Clearly, we can't have a situation where we're burying sneezing people, right? So why do we apply the same principles in data center operations? We've progressed far enough to know that, you want to know health states before a person dies. So why don't we apply the same principle into data center operations? So let's take in log data, which we can easily get, which we do today. Let's take in metrics data, and then we figure out, is it healthy or not? Can we do that? How do we do that? Now, let's pause on that. Let's look at it. Another situation. Let's look at spam. What's spam for me is not necessarily spam for you. What's spam today is not necessarily spam tomorrow. It evolves. And so, how do we handle spam? Many spam detectors are live learning systems. They feed on current data and they process, they then relearn. Yeah? And then you can tell the spam detection system, you've classified it incorrectly. This mail should be non-spam, or this piece of mail should be spam. And the system should then retrain itself. Yes? So, could we apply the same principles in monitoring, in understanding data center health? And let's get away from simply looking at dead or alive. And so from the point of view of the classifier, the classifier doesn't really care about whether the piece of log data coming in here is in relation to a web server, is in relation to a database server. It can be relatively generic. And to make it more interesting, you can then combine two arbitrary services, 2, 3, 4 arbitrary services. And the classification system should then look at it as, does it look anomalous? So in the context of a human, think of it as follows. You gather X-ray images and you put it through a classifier. Classifier understands whether this is picture of this is an anomalous picture or not. But the classifier wouldn't necessarily care. Once trained, it wouldn't necessarily care whether it's a picture of the chest or combination of head and foot. It will similarly work. It's a classification engine. Yeah? So, and this, the combination of services then enables us to track states, to track situations where one thing on its own, it could be perfectly fine, but the combination of them may present to be unhealthy. So now, let's take, for example, and this is a situation after you've detected that something is seriously wrong. So the situation of sickness here is one whereby you detect that the power supply unit is about to die. So how do you detect that? Now, if you pull in the current drawn per server, a perfectly healthy system, the current drawn would be quite flat. It's normal. If it rises, it's a gradual rise. If it drops, it's a gradual drop also. So fairly smooth curve. Yeah? But if you then see that the current drawn is this pattern, zigzagging, flapping pattern, that's unusual. How many of you here have dealt with power distribution units before? Aha, a few of you. Good. So you know this sort of flapping signature, it's a signature of the power supply unit about to die. Now, some organizations, they have the policy of running single power supply across their entire server estate. You may argue, well, what's 100 euros, 200 euros for a power supply unit? They would argue, well, 100 euros multiplied by a fleet size of 100,000 is no longer 100 euros. So, if you're then in a situation where you're running single power supply unit and you've got power supply unit about to die, what are you going to do? You're going to alert the operator? No. Because if you do that, you're going to have a situation where said young coder is going to scream, "Oi, you lot are bloody incompetent." We can't have that. So, we can't wait an alert. So what do? We flush the workloads. It's a cloud system running on VMs. Initiate flush of workloads, live migrate the workloads elsewhere, thereby ensuring continuity for the workloads. And then you can go and deal with the power supply unit about to die. It may not be dead yet, but you can go and check it out. There are multitudes of other situations where you really want to understand these 6 states before you get to the dead states also. Yeah. So the key takeaway here is that monitoring is not equals health. And really, for the cloud infrastructure operators, what's important is actually health, because you need to deliver that level of service that your users can then rely on to deliver the organizational goals, the flexibilities that the developers want, the program managers want, ability to deploy applications quickly. And so what we need really is to look at how could we have a system that actively tracks, learns, and then is able to apply the learned states into making subsequent decisions. So this is what we do in one of the things that we do in Sardina FishOS. It's got a bunch of other functionalities around resource management as well. This is where, for folks who are running substantial estates, we actively look at what is the actual resource consumption of every VM. So in our model, we do not have CPU, memory, disk, and network. Rather, we break the CPU down to what is it actually doing in the FP unit? What is it doing in the integer unit? What is it doing in the memory subsystem? So on and so forth. And then turning the model of 4 parameter CPU, memory, disk, and network into a 200 plus dimension problem. And then we play a massive jigsaw puzzle problem to pack them. And we do this continuously. This is one of our unique capabilities. And by doing that, we can then drop the energy cost, drop the TCO of the facility. Because we position ourselves as a products company, we aim at making the cloud platform easy to get going, well integrated, so log management, capacity planning, health monitoring, so on and so forth. It comes pre-integrated. And the topic of health that we just talked about is one of the functionalities in there. And today, we run at a number of sites, some in finance, some in service providers, and manufacturing or government. One of the government sites is quite interesting. They run single site, 150,000 VMs. It's quite a sight to see. In the UK, we also run the University of Edinburgh university-wide cloud, so serving some 40,000 people. The top right, this is the state of Baden-Württemberg machine learning cloud. And that's it. Any questions?
Any questions?
Comments? You've done it all wrong. I'm happy to be told that I'm wrong.
1 second.
Do you have any experience in this, where you said that you can have like machine learning or some sort of automatic classification of when a system is not performing, is performing well or not based on past data? How would you sort of balance that against systems for critical customers where you can't tolerate any false positives? I'm just wondering whether you have any sort of experience with that. Do you sort of run those test cases and see, okay, a system was the metrics that you were getting sort of indicated that a system might be going down, or so you don't take corrective actions or you don't flush the stuff because you might cause a performance degradation for your customers. I'm just wondering if you've had any experience where that sort of algorithms went wrong and it took down stuff where it shouldn't have taken down stuff. Okay,
so let me try to decompose that question. Okay, let's look at 2 parts. In a typical cloud system, you have the controllers, the control plane, and then you have the compute nodes, the hypervisors that are actually running the VMs. So, if we focus on the controller side, that doesn't affect the workloads. This is affecting the service being available. And so in a well-designed system, you should be able to actually pull power on any one of the controllers and the system should still be up. Okay? Now, as for the compute nodes, on the other hand, you got a question of, okay, if I'm detecting that something is not quite right on that node, whether due to software or due to hardware, then what can you do? Now, sometimes your action is actually alert the operator, but it's not a problem because it's not dead yet. It's still alive. At some other times, your correct action following is actually move it away. So, sure, whilst you're moving, any migration, you're going to have very short times when you're flicking over. That's usually a sub-second if you do it right. But if you can't tolerate that, then your question really is, can we afford? What's the lesser of the 2 evils? Do we live migrate it? Or do we take the risk of this thing being unavailable? You don't really have much choice. Yeah? This, for many environments, because of the separation of roles between the service consumer and the service operator, whereby the service operator's job is to keep the system available. The service operator doesn't care doesn't need to be concerned about what goes on in the VMs. And vice versa. The service consumer doesn't need to care about what the operator does to provide the service. Just provide it. It needs to be up. So if you have that clear segregation, then the operator wouldn't even be aware that this thing cannot be live migrated. The operator's job is to keep this thing up. I can't lose it. Okay, I hope that answers your question. Mm-hmm. Good.
Any more questions?
I'm happy to be told that I'm wrong also.
So why did you develop this in the first place? What was the need you wanted to address?
So this actually came out from a requirement at a bank. The problem statement was precisely what I mentioned earlier, where the segregation of roles and because of the organization size, the operator and service consumers were not tightly coupled. In fact, they were quite loosely coupled. And with any loosely coupled environment, the information flow between them is a lot less. And so therefore, there needs to be a degree of availability ensured so that the operations team can have the trust of the users. And so then we go back to look at how do we ensure that? And we've seen over and over again, straightforward monitoring doesn't work for a simple fact that you're alerting after the fact. Or some folks will want to try, we'll alert anyway, and then come up with tons and tons and tons of ways of trying to remove duplicate alerts. Many of us have seen that before also, yes? But the duplicated alerts, it shouldn't be there in the first place. So let's not fix the symptom, let's fix the underlying problem itself, because it's the underlying approach that needs to be fixed. And I hope that answers your question. Yeah?
I do have another question. So I'm seeing on the screen you have OpenStack in there and Kubernetes.
Yeah.
What about the other systems like VMware, AWS, Azure, Google? Is there any integration with them, or is it like you need to?
Because our audience are the folks who run Kit. So the customer is the guy who owns hardware and pays for electricity. That defines the user.
Okay.
So it's really the infrastructure operations team.
And is the solution only looking after infrastructure, or does it look into applications running on top of as well?
Let's answer the question a different way. The product is aimed at an infrastructure operator. The technology itself on the other hand, is not. So the health engine, it doesn't even understand OpenStack. It doesn't even know what on earth is OpenStack. It sees log data, metrics data coming in, and it will arbitrarily make decision. So we have a number of situations where we carve out specific parts of our product and make them available for certain users. So, and then the users can then do whatever they want on whatever other infrastructure. So another part of the product, it's called Service Manager, where we've applied this sort of philosophy. So Service Manager was originally built for situation where you have a large organization. They want to be able to provide their internal users with some way of requesting for OpenStack resources, certain 4,000. And then they want to be able to track that request, provision it, bill for it, etc., etc. So that is a service. But similarly, you can swap out OpenStack and you swap in anything else for which you can have a user requesting for. Provision can be actioned. Post-provisioning, that use can be tracked, and the usage can be billed. So that's a service manager. So we have done situations where we take these sorts of functionalities, they carve it out, customer uses whatever else that they want to do. So one of the situation is that the customer uses it to manage storage. They run several hundred petabytes of storage internally, and users could request for it, and they provide the shares. And that's not what we sell as part of the product, but it's dealt with our commercial teams to figure out how to carve it out.
Okay, thank you.
Okay.
I remember for one of your slides, you said one of the governments, they run like 150,000 VMs on one site.
Mm-hmm.
Could you give us a little bit more the reason why they are doing that, why there's no second site? How are they dealing with if the data center goes down?
Let's see. It's partly due to history. The users of the organization, they are all internal. They are not serving external users. So if a site goes down, it affects them and them only. It doesn't affect anybody else. Sure, it's a problem, but they don't have outside stakeholders. The other challenge is power. They are conveniently located next to a nuclear power plant. In fact, the organization happens to own it. It's not a commercial power plant. It's a research power plant if you want to look at it in that way. So, yep, they produce their own power. So you can't as easily go and find another power plant. Okay? Yeah.
One sec.
In this private cloud architecture,
Yeah.
is it OpenShift that underpins your Kubernetes engine from Red Hat? You mentioned OpenShift initially. Is it OpenShift that supplies the Kubernetes
No.
engine?
So if you look at the technology layer stack, bare metal, then OpenStack, and then Kubernetes run above it. And at that layer, you could run OpenShift also. So OpenShift for us, it's a user level, not infrastructure level.
Interesting, thank you.
Okay.
Any more questions?
By the way, why do you ask? It's interesting actually because I spend most of the day today with Google, their systems engineers, and one of their partners actually, because we're provisioning at this moment in time for a client, clients. And it was quite interesting in which what they were saying. It was quite similar to what you were saying actually, in terms of monitoring and health. Prometheus, it was made to me, I had to swallow the fact that Prometheus in itself is not proactive, it's reactive. In other words, it only tells you what has gone wrong. It doesn't tell you why it has gone wrong. And most cloud providers in the public cloud basically advise you, to either select one of the following, which is certified by Google. So what amazes me about the way you provisioned your Kubernetes engine is that you made it independent of any of the cloud providers, which is quite unique.
On-prem, yeah.
On-prem, yes.
Yeah, you can have, so we can have, for clients who don't want to do it on-prem, there are a few ways to do it. We could bring in one of our hosting partners, so they will host it, and separately, somebody manage the cloud environment. So you still get much better TCO than some of the public clouds. In terms of figures, something that, so if you look at VM to VM, excluding I/O, excluding network, excluding storage, straight VM to VM, yeah? Something that you get at Amazon at 10 cents per hour, a properly architected, properly run public cloud should be able to provide that same thing at sub 0.1 cent an hour. We certainly have clients that are providing similar things. At 0.1 cent an hour, they're already running positive margin. So that tells you what sort of costings it would be. And at some point, even if you bring in a colo operator, you bring in a service operator to actually run that cloud, it could still be a lot more efficient. Yeah. So we had a case where it's a chemicals company. The chemicals company, prior to engaging with us, they run some 500 odd physical servers, colo with one of their colo partners. And they wanted to move away from having to manage physical tin themselves. So the arrangement was that we bring up the private cloud at that very same colo, and then a service provider that actually runs the system is brought in to run the OpenStack system. And then, as the client transition from the old platform to the new platform, we could then flip over the servers and add the servers into the private cloud pool. And with that, they then grow their FishOS system.
Interesting.
Yeah.
Any more questions? Daniel has one.
You gave this example earlier about the power supply failing.
Mm-hmm.
And I imagine this is basically like a rack solution. So
Sorry, repeat, please.
a rack solution. So a customer buys a rack from you, which is completely integrated.
Okay.
Am I right? Is that true? So basically, you supply the whole rack with all the storage, of all the servers.
No. We supply the software.
You supply the
We
software.
supply the software.
Okay. So they can run it on their Dell, IBM,
Oh yeah.
HP hardware. Okay.
Yes.
Okay, so that makes it interesting, the question, actually. You with the power supply scenario you showed, how are you actually integrating into the power supply, power distribution units?
So depending on the PDU, we have essentially to pull from the smart PDUs via SNMP. So you parse the SNMP tree, and then you get the current data. But then when you're dealing with PDUs, there would have to be a period where you integrate, because PDU business being PDU business, you do not get only a single SNMP tree from the same PDU vendor. So it's quite typical that with one PDU vendor, you're going to get 20 different SNMP trees or more. It's quite common, but that's because of how those things came about. Some of those things, they came through, the PDU business, it's a relatively low technology threshold business. So you're going to get lots of entrants coming in, and each one of them have their own ways of doing things. But they grow to some point, and they are acquired by some of the bigger players. So the bigger players swallowed them. They applied their branding, but the underlying technologies are the same. So fast forward a few years, you're going to get lots of different SNMP trees as a result. We would, once we know what's the PDU being used for that particular site, then we'll work with the client to actually integrate that in. This is the same approach taken by pretty much anybody that deals with reading data out from PDUs. Yeah.
Sorry. Hi. So you spoke about PDUs, but there's lots and lots of different hardware components that have similar patterns of failure, so disks and motherboards
Yes.
and all sorts of things.
Yes.
What sort of, given that you've got all those things to integrate with, and I'm making an assumption, I suppose, that you ingest all that sort of data as well and
Yes.
predict things that way.
Yes.
What sort of lead time is there to integrate your average client's infrastructure into your systems?
Depends. So, it depends on a lot of different factors. Now, first off, the extent of what you need to integrate that are specific. So PD is one of them. Disks, they don't present so much of a problem because disks you're reading out from, you're reading the smart data. So smart data, you don't have that many patterns that you're parsing for health of the disks. The other thing that you want to get is NIC data. So you want to know whether there's a lot of drops. You also want to know if you're getting lots of ECC errors. So ECC errors, you can pull that out from the BMC. And BMC, there aren't that many different ones if you consider only the major players. Having said all that, yes, you still have some number of combinations. If it is a contract where the server vendor is the prime, and the server vendor can bring up the system, they can stand it up at whatever staging site, which is quite common for some of the large deals, typically government deals, where they're required to have pre-staged. Then we can deploy the full OpenStack environment in factory. And then when it gets to the staging site, we figure out, okay, what needs to be integrated. And once we know what to read out, the site-specific scripting, that's easy. Okay? And for those kind of systems, they are very often they are uniform. I won't say that they're always uniform, but very often they are uniform. I've seen a situation where a customer orders a circa 1,000 nodes, and this particular hardware vendor, yes, they delivered 1,000 nodes. The BIOS versions were not all uniform. Heck, the BIOS vendors were not all uniform. The specification was that the client says at least X gigabytes of storage per node. And guess what? The server vendor delivered at least that, which meant that some disks on the nodes were X, some were X++. Have fun. And they delivered the nodes with multitudes of different DIMMs. So yeah, the probability of getting into that kind of situation is not nil, but it is not often.
Any more questions?
why did you select OpenStack as a private cloud platform?
Whew, that's a question going back in time. So, a long while ago, we observed a situation where a particular bank basically have workloads running on this large farms of servers no more than 8 hours a day. So in other words, 2/3 of the day, this thing was sitting idle. It's a glorified heater. So the idea at that time was, right, so what can we do? This is money that's being burnt. So, okay, if we could shove the workload into VMs, and then if we could have some ways of understanding what's the live resource utilization of the VMs, we can therefore understand that it is idle. For example, when it is idle, we figure out how to optimally pack them onto as few physical servers as necessary to keep them alive. Don't kill them, just keep them there. That would allow us to turn off the excess machines. And then as we detect that these VMs are getting busier, we can then flow them back out again. That was the original concept. And that was the problem that we wanted to solve. We went and developed the technology to do that. And yeah, V1 of the solution was crap. We learned how not to do things. Anyway, luckily V1 was for internal consumption, not for external. So at that point, we saw that, okay, we have a engine to make this decision. What do we need to plug into to actually have that actual cloud infrastructure? And so our first target platform wasn't actually OpenStack. First target platform was OpenNebula. So that tells you when that was. And then at that point, we thought, now that we've done OpenNebula, can we do anything else? This thing, OpenStack, lots of people are talking about it. Let's go check it out. And that's how we got to dealing with OpenStack. We started dealing with OpenStack when it was Backsar, so release B, quite early on. And that subsequently became the platform that we adopted. And at some point, whilst our original technology was in resource management, increasingly customers were telling us, actually, guys, we want you to not just do that. Yes, that saves us money once we get to the operation, but we need something to get us into operation first. And so that's how we then branched out from there to address the deploy phase of the cloud into the operate phase, and then subsequently to the upgrade phase. And this is also a distinct difference between us and some of the other OpenStack players, that they mainly came from the deploy phase first. So they spent a lot of time on the deploy phase, and sometimes they go through lots of they've gone through a number of iterations on the deploy phase. We came a bit later into that part. Yeah.
It's quite, the OpenStack framework implementations architecture have been known to be really difficult. It's not easy. I mean, I give you kudos. I've been part of a couple of projects that have failed with OpenStack.
Yeah.
Now, the public cloud providers like Azure are now having this modules called the Azure Stack, which basically is a hybrid environment where you can extend your existing networks.
Yeah.
What do you think about them? AWS just recently announced their own version of, it's called Outposts or something like that, where you basically extend your networks, the existing networks, and only share connectivity you do, and it's metered to only what you use. And it gives you the advantage of using their own, say, Kubernetes engines, their own facilities, and you only pay for what you use. What do you think about them? That's the new trend that is going now.
You can ask the Chinese government what do they think about that. And the Chinese government would say, absolutely not. So some sovereign states, their policy is still no. Clouds have to be in country. And we're talking even some European countries. So, and in regulated markets, there will be a lot more push for in-country workloads. And in some countries, the definition of in-country extends all the way to ownership. Not just the data center happens to sit here. So those are some of the example situations where it won't necessarily fit with the customer's needs, regardless of cost. Now, in relation to your comment about OpenStack is difficult, I would agree 101%, but I will also disagree 101%. Because now, conceptually, what is OpenStack? I can tell you what OpenStack is. OpenStack is, it's a bunch of web services plus a database plus a message queue, and that's it. So when it comes to doing HA for these things, we've been doing HA for web services for eons. Easy. We've been doing HA for databases. Similarly, for eons, we can do it. HA for message queue, again, it's a very mature topic. So the challenge around OpenStack is very much the challenge around Linux. Now, do you build your own Linux distribution? No. Right. Do you even build your own kernel? Probably not. But when it comes to OpenStack, this is one of the reasons not to use upstream. I know some folks who will try to use upstream, but no. Why do you do that? You don't pull in packages directly from whichever source and then try to string together your own Linux distribution. So similarly, don't do that. There's a reason why distributions exist. And then, once you're looking at a distribution, sure, there are differences in how you deploy. At that point, you look at why the deployers of the various distributions are crafted in those specific ways. What were they crafted for? So now I can tell you how we do things. We go into an environment, we would want, so first off, our OpenStack deployer and our base OS deployer are completely separated. So this enables us to go into an enterprise and say, right, you enterprise are using tool X to deploy a base OS. Continue doing that for your OpenStack environment. So you've deployed your base OS on the physical machines, and then you bring in Fish OS deployer. You fill in the configuration file. It's Ansible based, and you hit run. You go for 2 cups of coffee. You come back, assuming that this is a system that fits our blueprint. It's done. No other work needed. So the philosophy behind it is that we want to easily fit in to enterprise environments. And we want the product to be easily deployed without having to engage in 3 months of consultancy to bring up the environment. We've certainly seen those kind of situations before. Now, if the product is aimed at enabling you to bring it up quickly, simply, then you no longer need consultancy, and therefore your bring up is that easy. Now, consider this. 1995, if you were to ring up a server vendor, whichever one, take a pick, and you say, Mr. Server Vendor, I want Linux on my servers. What would they tell you?
The kernel then was still mature, run workloads, massive workloads, 1995.
Yeah, 1995. In all sorts of different ways, they will tell you no. Yeah? 2019, you ring up the server vendor and you say, Mr. Server Vendor, I want Linux on my servers. You get a question, which one? When? So what's the difference between 1995 and 2019? The guy in the factory still doesn't understand what on earth is Linux. So how did the server vendors manage to get to the point where they're able to tell you which one and when? The secret of how they're able to do that, the answer to that is that they've automated the process. So today, with FishOS, you can do in-factory deployment. Yeah, and that's where we're aimed at. And for the server vendors, their way of deploying the system is actually in 2 steps, very much like an enterprise. First, you deploy base OS, which they can automate already, and they deploy FishOS on top, which they can also automate. Okay?
You just mentioned Ansible. I suppose they'll be doing the same thing with things like, they'll probably be doing the same thing with, say, some configuration management tools like Ansible or Chef or something, the factory levels. That's fine.
Yeah. Okay, I hope that answers.
That's yes. It does in parts. It's just that, like I said, OpenStack, you've made it look easy. Well, look, procedurally easy, but it's when you look at failed projects using OpenStack, they're quite massive. That's why midstream, a lot of people abandon it and probably go for a service provider.
My only answer for that is you don't spin your own Linux distribution. why take that approach with OpenStack? Yeah? Okay,
Thank you.
good.
Any more questions? Daniel? 1 second.
So you said the customer installs the base OS in whatever way they use it or they can. So do you have any preferred distributions or are you take any distribution?
Yes. CentOS or Red Hat? Yep.
Yeah, so we're same thing, yeah. No SUSE, Linux. Okay.
So long as they're called CentOS Red Hat, yes. You can have any distribution of Linux so long as it's called CentOS Red Hat. That's simply because our RPMs are built for CentOS Red Hat environments. We are a very old school style of company when it comes to packaging. Everything is RPM'd. There's no Docker packaging.
Okay.
Sorry, how much do you diverge from Red Hat's native OpenStack implementation?
How much do we diverge? Release to release, the answer differs. Most of the time, RPM to RPM, we have the same names. The contents may not be the same. And sometimes ours contain certain patches, theirs don't. So we do have situations where the customer says, the RPM has to originate from Red Hat, but they want to use our tools. We can do that. And then we apply patches based on the situation for certain pieces. That kind of situation, it's two cases. One is where they have site-wide license already, and they say, yep, whilst we have site license, even though we'll pay the same price for your product, we still want to use Red Hat RPMs. So from my viewpoint, the customer pays me the same. What am I going to do? Say no? Absolutely not, right? So we can integrate that way. But in another situation, this is in one of the European countries where the banking regulator, their national regulator actually says it has to be Red Hat. Yes, I know, very convenient for Red Hat, but that's besides the point. Okay? But the Red Hat deployment model is different from ours. So Red Hat deployment model, it's got an undercloud and an overcloud. And that's one of the situations where this gentleman's comment that it's bloody complex is certainly very true. Ours, it's straight bare metal everything. Easy. You understand RPMs? We're good to go. Okay? You're going to hold everybody up from
I know.
beer, food.
Yeah, I know. Sorry. That was the question. So if I'm understanding this correctly, so you have a bare metal machine.
Yep.
The customer installs Red Hat or CentOS on the machine, or
Yep.
Oracle Linux maybe.
Yes. You can have anything so long as it's called Red Hat or CentOS.
Okay. And then you install your VisualOS on top
Correct.
as a service, I guess, as
Yes.
just a standard Linux service.
Yes.
Okay, cool. And are you installing OpenStack as part of that as well, as part of your
Correct.
VisualOS? Okay, okay. Okay. Then also, are you rolling your own Kubernetes as well with patches, or are you using the standard distributions?
It would be standard distribution.
Okay, okay.
And the the Kubernetes clusters are provisioned through OpenStack Magnum. So you basically have Kubernetes as a service through OpenStack.
Okay. So the Kubernetes is mainly as containers.
Yes.
You also talked about VMs. So what is actually on the VM side?
So the containers.
Yeah.
So the containers run inside the VMs.
Mm-hmm. And they're hosted in KVM, or what's the?
Yes.
Okay. So you're because we are mainly a Windows crowd. Yeah.
That's right.
The question is, are you also having customers with Windows VMs, not containers?
Yeah.
Okay. So you're basically mixing Windows and Linux.
Yeah, you can do all that because KVM will support these variants.
Mm-hmm. Okay.
Okay.
So who supports KVM if something goes wrong? I mean, for example, let's say the VMware example. VMware supports Windows and Linux, certain versions on their platform. But VMware is, of course, a big provider. They do their own thing. So who supports KVM on that side? For example, VMware has like their own tools. They install drivers and other services into the VM for monitoring and other stuff. So who supports KVM?
So there are 3 different parts of the answer here. So first off, the question is who supplies the KVM? If the KVM package supplier, i.e. the RPM supplier, is Red Hat, you deal with Red Hat. We can handle dealing with Red Hat on the client's behalf. But ultimately, the supporting party for that RPM is Red Hat because it originates from Red Hat. If the client contracts us to support full system from Metal up, then we are the party providing full system from Metal up. And that would cover not just KVM, but the whole shebang. Okay?
Something you emphasized as well was operators.
Sorry?
Something you emphasized as well were operators. So it's very much you want to help the operators with this solution, with this product. So how does it look like from an operator perspective? What are they interacting with a website? And so once you have deployed this product, what does it look like from an operator perspective? What are the touching points with the system?
Okay. So how do you interact with the product? So as for the OpenStack part, it is OpenStack through and through. So you deal with Horizon, the web UI part, or you can do command line, or you can talk to it through OpenStack APIs. And each part of the additional functionality, they have their own UI. So, for example, the health part, it's got its own UI, dealing with just the health part. And then the service manager that I mentioned, that's again standalone on itself. Yeah. So yes, it's got the downside of you don't have a single integrated UI, but it means that you can pull them apart quite easily. And we also have situations where the client doesn't necessarily use everything, but will ship the full package. So you then don't lose any functionalities simply because you're not using another piece. Okay? Mm-hmm. Good. Good.
No? Okay. Good. Thank you very much.
All right. Thank you, everyone. Thank you.